Okay, this is problem 67 in section 3.1, and we're given a second degree equation. It says f of x equals ax squared plus bx plus c, and it says that that has a vertex at the coordinate 0, 2 and passes through another point 1, 8. We're supposed to find a, b, and c in this quadratic equation. Since we're given the vertex, then it makes sense to use the vertex, the form of the quadratic that actually uses the coordinates for the vertex. So we're going to start off with actually writing out the general form of the quadratic where it uses the coordinates for the vertex, which is a times the quantity of x minus h quantity squared plus k, where h and k are the coordinates for the vertex. So what we're going to do is we're going to substitute in the points, or the point of the vertex. For h, we put in 0, since that's given for the x coordinate for the vertex. K is 2. And now inside we can simplify this equation because x minus 0 is 0, and that quantity is squared, so it'll be ax squared plus 2. So now what we're going to do is we're going to find out what a is by substituting in the other point into this equation. So we just simplified the general form of the equation by substituting in the coordinate for the vertex and got this f of x equals ax squared plus 2. And so let's substitute in the point 1, 8. And the 8 is the y coordinate, so that goes in for f of x equals a times, and then the x coordinate is 1, quantity squared plus 2. So we just substituted in the 0.18 into this equation. And simplifying, we get 8 equals a plus 2. Subtract 2 from both sides. And then we get 6 is equal to a. So we found a. Our instructions were to find a, b, and c. And so what we're going to do is we're going to substitute a back into our standard form for that quadratic using the coordinates of the vertex. So let's go ahead and do that. Substitute in a, which would give us, well, let's just write out the thing again here. It's x minus h squared plus k, substituting a, which is 6, and substituting in again the vertex, x minus 0, quantity squared plus 2. So now what we're going to get is, when we multiply this out, the goal of doing this is we can actually then get it into a form where we have ax squared plus bx plus c. So you can take this form here of the standard form for the quadratic that has the coordinates for the vertex, and then convert it into the other form where it's ax squared plus bx plus c. And you do that just by simply multiplying, substituting everything in and then multiplying it out. So that's what we're doing. And so then we get, it'll be 6, x minus 0, of course, of 0, quantity squared is x squared plus 2. So, when you compare that with, this other form of the quadratic where it's ax squared plus bx plus c, a is equal to 6, which is right here. And then b is 0 because there is no x term in this x squared plus 2, 6x squared plus 2, so b is 0. And then c is 2. and then you're done.